we are going to talk about real-time software design and real-time software design. It's designing embedded software systems whose behavior is subject to timing constraints. A system is said to be real-time if the total correctness of the operations depends not only upon its logical correctness but also upon the time in which it is performed. So real-time systems which monitor and control their environment. Time is critical. Real-time systems must respond within specified times, inevitably associated with hardware devices, sensors and actuators. Sensors collect data from the system environment. Actuators change the system's environment. So definition of the real-time software design. A real-time system is a software system where the correct functioning of the system depends on the results produced by the system and the time at which these results are produced. Soft real-time system whose operation is degraded if results are not produced according to the specified timing requirements. Hard real-time system whose operation is incorrect if results are not produced according to the timing specification. So stimulus response system. Given a stimulus, the system must produce a response within a specified time. Periodic stimuli and aperiodic stimuli. Periodic stimuli means stimuli which occur at predictable time intervals. For example, a temperature sensor may be polled 10 times per second. Stimuli which occurs at unpredictable times. For example, a system power failure may trigger an interrupt which must be processed by the system. Architectural consideration. Because of the need to respond to timing demands made by different stimuli responses, the system architecture must allow for fast switching between stimulus handlers. Timing demands of different stimuli are different. So a simple sequential loop is not usually adequate. Real-time systems are usually designed as cooperating processes with the real-time executive controlling these processes. So this is the real-time system model. So it's in the real-time system model, it's a real-time control system. It directs out to the various types of sensors and actuators. So sensor and actuated process is this. First sensor will give the stimulus, so sensor control can control the data processor and actuator control responds the sensor signal. Sensors control processes. Collect information from sensors. May buffer information collected in response to a sensor stimulus. Data processor carries out processing of collected information and computes the system response. Actuator control generates control signals for the actuator. So system design. Design both the hardware and software associated with system. Partitions functions to either hardware or software. Design decisions would be made on the basis on non-functional system requirements. Hardware delivers better performance but potentially longer development and less scope for change. And this is the hardware and software design architectural diagram. So establish system requirements and partition requirements. Partitions should be in two ways. One is software requirements, one is hardware requirements. For both we should get some designs regardingly. Real-time system design process. First, identify the stimuli to be processed and the required responses to these stimuli. Second, for each stimulus and response, identify the timing constraints. Third, aggregate the stimulus and response processing into concurrent processes. A process may be associated with each class of stimulus and response. Fourth step, design algorithms to process each class of stimulus and response. Fifth, design a scheduling system which will ensure that processes are started in time to meet their deadlines. The last one, integrate using a real-time executive or operating system. State machine model. The effect of a stimulus in a real-time system may trigger a transition from one state to another. Finite state machines can be used for modeling real-time systems. However, FSM's models lack structures. Even simple systems can have a complex model. The UML includes notations for defining state machine models. And this is the microwave oven state machine. and this is the one of the example for sensors and actuators. So and hereafter we'll have some assessment, and we'll see the further topics next video. Thank you.